Hello there students, I am Teacher Madeha and today we will be discussing about permutations. In this lesson, you will learn how to illustrate permutation of objects, how to find permutations of n objects taken r at a time, and how to solve problems involving permutations. Have you ever wondered why some locks have codes in them? Do you know that a shorter code is a weak while a longer code is a strong personal password in a computer account? Have you ever realized that there are several possible ways in doing or performing tasks or activities like planning a seating arrangement or predicting possible outcomes of a race? Now, in these situations, permutation is a great help. And in this lesson, you will learn how permutations can help you in forming conclusions and making wise decisions in life. Now, think of this. In how many ways can Erica, Sky, and Race arrange themselves in a row for picture taking? Let's try to solve the problem by listing all possible arrangements. Meet Erica, Sky, and Race. Let's start. First arrangement, we have Erica, Sky, and Race. Next, we have Erica, Race, and Sky. Third, Sky, Erica, and Race. Fourth, Sky, Race, and Erica. Fifth, Race, Sky, and Erica. Sixth, Race, Erica, and Sky. Can you still think of another arrangement aside from those 6? Okay, none, of course. So therefore, there are 6 arrangements. We have the first, second, the third, the fourth, and fifth, and sixth. So in this case, by listing all possible arrangements, we have 6 arrangements. Therefore, by listing all possible arrangements, there are 6 ways that Erica, Sky, and Race arrange themselves in a row for picture taking. Now, what if there are 5 people? In our previous example or problem, there are only 3 people. It's easy for us to list all possible arrangements. But if there are already 5 people, can we easily list all possible arrangements or possibilities? It's very tasky to list all possible arrangements. So in this case, or in this situation, we need the permutations. But what is a permutation? A permutation is an arrangement of all or part of a set of objects with regard to the order of the arrangement. The permutation of n objects taken r at a time is denoted by the permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial if n is greater than or equal to r. And the permutation of n objects taken all at a time is denoted by the permutation of n objects taken n at a time is equal to n factorial. But what does the given symbol mean? In English, we know that it is an exclamation point. But here, in our discussion, that is not an exclamation mark. That is a symbol that denotes a factorial. In mathematics, the factorial of a positive integer n, denoted by n factorial, is the product of all positive integers less than or equal to n. For example, we have 5 factorial. What does this mean? This means that we have to multiply 5 by 4, then 3, 2, and 1. So 5 factorial means 5 times 4 times 3 times 2 times 1. And 5 times 4 times 3 times 2 times 1 is equal to 120. Therefore, 5 factorial is equal to 120. Now, again, remember that the permutation of n objects taken r at a time is denoted by the permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, given that n is greater than or equal to r. And if n is just equal to r, then we have the permutation of n objects taken n at a time is equal to n factorial. Again, the second formula is being used if n is equal to r. Now, let's try to have some examples. Given a 4-letter word READ, in how many ways can we arrange its letters 3 at a time? Now, in this case, there are 4 letters. Therefore, n is equal to 4. And we're going to select only 3 of its letters. So, r is equal to 3. Now, since n is greater than r, we are going to use the first formula, which is the permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial. So, since n is equal to 4 and r is equal to 3, just substitute. So, we have the permutation of 4 objects taken 3 at a time is equal to 4 factorial over the quantity 4 minus 3 factorial. So, this means the permutation of 4 objects taken 3 at a time is equal to 4 times 3 times 2 times 1. And 4 minus 3 is equal to 1. Therefore, we have 1 factorial as the denominator. So, 4 factorial means 4 times 3 times 2 times 1. 4 times 3 is 12, times 2 is 24, times 1 is 24. So, we have the permutation of 4 objects taken 3 at a time is equal to 24 over 1 factorial, or just 1. So, we have the permutation of 4 objects taken 3 at a time is equal to 24. Therefore, there are 24 ways. Okay, let's have another example. In how many ways can 5 people arrange themselves in a row for picture taking? So in this case, there are 5 people, so n is equal to 5. And all of them will be selected, then therefore, r is also equal to 5. So since n is equal to r, therefore, we are going to use the second formula, which is the permutation of n objects taken n at a time is equal to n factorial. And since n is equal to 5, we have 5 factorial. So 5 factorial, as we have known, is equal to 120. So therefore, there are 120 ways that 5 people can be arranged in a row for picture taking. Now, let's try to have another example. Let's try to find the number of permutations of the letters of the word statistics. What have you noticed in this problem? How can you compare it to the first example or problem that we have solved? The first problem the word there is R-E-A-D. And in the word R-E-A-D, there are no repetitions or duplications of letters. But in this case, in the word statistics, there are repetitions or there are repeated letters. How are we going to solve this? What is now the value of n? What is the value of r? So, if we can notice, there are 3 S. There are also 3 T's. And there are 2 I's in the word statistics. Can we still solve this using the first and second formulas? We cannot solve this using those formulas because this is another type of permutations. This is called the distinct or distinguishable permutations. The number of distinguishable permutations P of n objects where P objects are alike, Q objects are alike, R objects are alike, and so on is denoted by the permutation or the distinguishable permutation is equal to n factorial over P factorial times Q factorial times R factorial and so on. So this is a distinct or distinguishable permutation. So this will be the formula that we are going to use to solve example number 3. Distinguishable permutations can only be used to those objects with repetitions or with duplications. So, let's go back to example number 3. Let's find the permutations of the letters of the word statistics. So, in this word, we have 3S, 3 T's, and 2 I's. This means that 3S meaning 3 factorial. Then 3 T's mean 3 factorial. And 2 I's mean 2 factorial. And there are 10 letters, therefore the value of n is 10. Therefore, to solve this, we have to divide 10 factorial by 3 factorial times 3 factorial times 2 factorial to eliminate the duplications. By using the formula, the distinguishable permutation is equal to n factorial over p factorial times q factorial times r factorial and so on. So since n is equal to 10, we have 10 factorial. And p is equal to 3, we have 3 factorial. And q is equal to 3, we have 3 factorial. And r is equal to 2, we have 2 factorial. So 10 factorial means 10 times 9 times 8 times 7 times 6 times 5 until 1. But in this case, we will stop at 3 factorial because later on, we're just going to cancel it with 3 factorial at the denominator. So p factorial is 3 factorial, then q is 3 factorial, and r is 2 factorial. So we cancel, that means we divide 3 factorial by 3 factorial, so that's 1. And we all know that 3 factorial is equal to 6. So we divide also 6 by 3 factorial. Then we have the product as 100,800 divided by 2 factorial or just 2. So dividing it, we have the distinguishable permutation is equal to 50,400. Therefore, there are 50,400 distinguishable permutations. Alright, let's have another example. In how many ways can 4 people be seated around a circular table? What have you noticed in this problem? What is now the arrangement? Is it in a row? No, It's not in a row. The arrangement is not in row, but rather it is in circular formation or circular arrangement. So can we still use the first and second formula or the third formula? No, we can no longer use the first, second, and third formulas that we have used. This time, it is another type of permutation. It is called the circular permutation. What is a circular permutation? Or what are circular permutations? These are arrangements of objects in a circle, or these are the different arrangements of objects in a circle. It is denoted by the circular permutation is equal to the quantity n minus 1 factorial. Going back with our example, in how many ways can 4 people be seated around the circular table? In this case, there are 4 people, therefore n is equal to 4. By substitution using the formula, we have the permutation or the circular permutation is equal to the quantity 4 minus 1 factorial. And 4 minus 1 is 3. And therefore, 3 factorial is equal to 6. Therefore, there are 6 ways that 4 people can be seated around a circular table. Alright, we're almost done with our lesson. Let's go back with the concepts that we have learned from this lesson. We have learned about different arrangements. We have arrangements in row. We have also arrangements in circular formation or circular arrangements. And also, we have learned how to calculate or find the permutations of those objects with repetitions or duplications. And take note that in these arrangements, order is important. We have learned about permutations. Take note that the permutation of n objects taken r at a time is denoted by the permutation of n objects taken r at a time is equal to n factorial over the quantity n minus r factorial, given that n is greater than or equal to r. But if n is equal to r, we have the permutation of n objects taken n at a time is equal to n factorial. We also learned that there are other types of permutations. We have the distinguishable permutations, denoted by the permutation or the distinguishable permutation is equal to n factorial over p factorial times q factorial times r factorial and so on. Take note that we can only use this formula for those objects with duplications or repetitions. Next, we have the circular permutations. Circular permutation is denoted by the permutation or the circular permutation is equal to the quantity n minus 1 factorial. And we can only use this formula or the last formula about the circular permutations if we are given arrangements in a circular formation. Right, I think you are ready for a short quiz. Kindly get the paper and the pen. Are you ready? Okay, let us start the test. Number 1. The teacher wants to assign 4 different tasks to his 4 students. In how many possible ways can she do it? Start. Okay, stop. What's your answer? If your answer is 24, then you are correct. There are 24 ways. Number 2. How many distinguishable permutations are possible with all the letters of the word ellipsis? Start. Alright, kindly stop. What's your answer? If your answer is 5,040, then you are correct. There are 5,040 permutations. Number 3. Find the number of different ways that a family of 6 can be seated around a circular table with 6 chairs. Start. Okay, kindly stop. What's your answer? If your answer is 120, then you are correct. There are 120 ways. Okay, congratulations if you got a perfect score. Okay, congratulations! We're done with our lesson for today. In this lesson, you have learned how to illustrate permutation of objects. You've learned how to find permutations of n objects taken r at a time, and how to solve problems involving permutations. If you want more examples, you can read Mathematics Grade 10 Learners Module pages 283 to 297. So, that's all for today. See you in our next video lesson.